Hello, everyone. Welcome to episode 26 of the Day Zero podcast. I'm Spectre. With me, as always, is Z. And yeah, we're going to jump right into some news and discussion. But before that, actually, I do want to say that we have been getting back into doing the streams on the Fridays. Some of you might have noticed that I had the stream going the previous Friday, looking at some PS4 stuff, because I'm very rusty on the Android stuff. I'm not even entirely sure where everything is for that. So, yeah, so we should be back to doing the streams on the Fridays. So those of you who are interested in that, we are back to that.
So I guess
yeah,
on that, how did it
Okay.
go? I wasn't able to watch you.
It went pretty well. I was doing some PS4 stuff, so
Yeah,
for those
that's
that
still
don't
the
follow
toolkit.
me, yeah, we're working on a tool chain for the PS4 to build homebrew applications without using the Sony SDK, right? So you can avoid the potential legal issues with that, right? Because technically the SDK is copyrighted. So yeah, we were working on that, but because it's a custom tool chain, we did hit some bugs during the stream that were very hard to track down, and we were having a bit of fun. And ultimately, what I was trying to do didn't work out, but that's just how it goes sometimes.
Well, you had fun along the way.
We had fun along the way, yeah. So yeah, we should be continuing that on the Fridays. So those of you who are interested, be sure to tune into that. So we'll jump right into some news. So something that happened this week was Pwn2Own Miami. So this one was largely focused on IoT stuff, as you were saying a little bit before the stream. And one team, as is custom with a lot of the Pwn2Owns, completely, they dominated pretty heavily, I'd say.
I've got the scores up. I mean, it's a 5-point difference between first and second place. Yeah, I mean, it definitely steeply drops off from there, but I don't know. I mean, I wouldn't necessarily say that's dominating.
It's not as bad as the last one.
Yeah, no.
For sure.
And this one was, all IoT focused, so I'm not too surprised to see kind of higher scores all around.
Yeah.
At least from what I remember. I don't actually recall what last Pwn2Own's scores were, so maybe I'm wrong by that.
But one thing you were mentioning was there's a lot more teams or a lot more contestants, it seems, in this one compared to the last Pwn2Own that we covered.
Or at least contestants that scored.
Yeah, exactly. But another thing that I noticed was there was quite a bit more like failures or partials on this one than I've seen before, which I found a bit interesting. Some of them couldn't get their bug to work, and there were some that were fixed, like the issue that the exploited was fixed. And on those partials, they still got the master pwn points, but they didn't get the money, obviously, and the amount of points they got were halved. So, it was kind of interesting. There was more competition, but there was, some more failures and stuff, but it was more IoT focused, as you were saying. So, I
it
guess
looks like about 9 partials.
Yeah. I mean, to be honest, because of that area, as much as IoT stuff is typically buggier, it can be a little bit harder to exploit sometimes, just because you are working with embedded, right? Like, often you don't have a common kernel running on them or whatever, right? Like, sometimes you will have something like the Linux kernel, but a lot of times you are dealing with
some unique challenges
too. There's some unique challenges.
You're also, though, in a lot of cases, some stripped out security features. So I think it can kind of balance out a bit. I mean, yeah, you've got some unique cases to it with embedded, probably a lot of cases maybe running a real-time OS or something like that. Or, I mean, maybe they're going crazy and running a microkernel or some of the other options that they could go for. But I ended up kind of forgetting to look up about the Pwn2Own, besides adding it that we should talk about it. So I haven't had a chance to really look at what all the exploits were, what was being tested here. But I would maybe come down saying, like, it has its unique challenges, but generally speaking, it seems like IoT is less secure. I know during the last Pwn2Own, a lot of the IoT stuff were routers.
Yep.
So, I mean, those... You expect your gateway to the internet.
This one, I think, was focusing on, like, automation factory talk, like Rockwell stuff. I'm not entirely sure what that is, if I'm to be honest. But I saw that mentioned a lot. So... I'm not too familiar with like the some of the IoT stuff. You're gonna quickly look it up.
Yeah, well, let's see what comes up with it. Looks like
It looks like something maybe
Looks
for
like a
dealing
country
with, like,
list coming up on my screen.
okay, I was thinking maybe something to deal with what are they called? I can't think of the name.
Either way, I mean, IoT
yeah.
stuff, we haven't had a chance
But like
to look
industrial,
what we've
basically, is
got.
what I was thinking of. Managing industrial control systems.
Yeah,
And stuff like
so, I mean, I wish I would have had more time. I'm pretty sure somebody pulled out. They have, like, one of the companies that they've had in the past ended up pulling out of this.
that. Oh, really?
Pwn2Own.
Okay. I didn't see that.
Like I said, I'm sorry I don't have kind of proper notes. But
That's
I guess what happened basically is one of them now has their own bug bounty program, so they're not going through ZDI. And thus they just kind of pulled out. That's my understanding. Again, I don't have the company name to actually mention what it was.
Oh, fair enough. Yeah, so I think the next Pwn2Own's probably going to be Vancouver, I think, in August, like last year. I'm not entirely certain on that, but I'm thinking that's what the next one is. So
yeah, for CanSec West.
Yeah. So, we'll keep a lookout
is
for
in
that.
March. Pwn2Own should be there.
Oh, it's in March. Okay. I thought
March
it was
18th.
Later on. Okay, cool. There we go. But yeah, like, it's always fun to see what's going on with Pwn2Own. So in some bigger news, though, that happened this week, we had the Jeff Bezos phone hack situation. So, of course, we're going to talk about this. So, for those of you that, like, didn't see it or whatever, last year, there was, like, a big scandal where, like, the Inquirer, I think it was, leaked text messages concerning an affair with Jeff Bezos. And there were a lot of political shitstorms around this, right? Concerning, like, Saudi Arabia and Trump and AMI and all these, big names. So there were investigations launched. And after a more recent forensics investigation, it was concluded with high confidence that that Saudi Arabia had access to Jeff Bezos' phone, that they had spyware on it. Apparently, from, like, the technical details I could gather, so we have the United Nations Human Rights Office of the High Commissioner page open for this, where they talk a little bit about some of the technical details of it, not too in depth, but they say that the exploit was apparently in the MP4 video parser of the of WhatsApp, I think.
Yeah, I mean, I'm wondering if this is related to the MP4 video that we've talked about, because I know
was thinking about that,
and the one that
I remember that.
I can't remember what her name is right now, but the Project Zero researcher that she was covering, and it was mentioned that Maddie Stone.
Maddie Stone, yeah.
Yes.
Okay.
And she was mentioning, I believe, that they saw that as being actively exploited. So it's not confirmed here, but considering, we now know about this exploit, I have a feeling that's probably the same one that was used back in, I guess, 2018 for this. And they mentioned it was used to install NSO groups, spywares.
Yeah, so they say, like, they don't really go into details of, like, if they know for sure that the exploit was in the MP4 video parser, but they said within hours of receiving an MP4 from an account that belonged to the Saudi Crown Prince, I think, they said massive amounts of data was exfiltrated from the phone. I think it went up to, like, 4 gigs or something.
Yeah, that's what they mentioned, 4.6 gigs.
Yeah.
But, I mean, yeah, they can't say with 100% certainty that that's what it was, especially if they had the chance to kind of remove some of their traces before forensics and stuff got involved. They can't be, 100% certain about anything, but there's definitely some correlations that you can see here. Like, you see, the MP4 comes on, you see that happens. Like, you can make a pretty reasonable guess about what happened, even if you can't be 100% sure. So, I mean, there's going to be a lot of those comments where it's like, they're not completely certain, but, the facts are this happened and then this happened. And, you can draw your own conclusions from that. I mean, we're not the court of law, so we can be a bit wrong on that. But, I mean, it seems like there's a pretty high confidence here.
Yeah. I mean, at first I was kind of on the edge because the reporting was kind of vague. They were saying, like, we think it was hacked through WhatsApp and whatnot, but it was like, okay, but, you need a bit more technical information. But after I saw some of those explanations in this UN
Yeah,
post.
this has, like, I mean, it's not a lot of technical information, but it has a lot of the right information.
Yeah, like it seems a lot more likely now. I will say though, there were some inaccuracies in the forensics report. I think I saw an interesting tweet. I'm going to bring it up right now. Actually, it was by Dino A Zovi. I think I said that right. But they were saying that due to end-to-end encryption employed by WhatsApp, it is impossible to decrypt the contents of the downloader file. And that bugged him so much that he wrote up a GitHub repo on how to actually do just that. So, you know, there is a bit of there is something that can be challenged in the report. So, you know, that is worth taking into account, I think.
I mean, that could even just be something that, you know, there's obviously political incentives to call out end-to-end encryption. I don't know, you know, FTI Forensics necessarily is going to be the company doing that, but I could understand if there's a little bit of pressure or something of that nature for them to do so.
Yeah. So on the topic of phones and, you know, security of them, this spawned kind of a discussion, right? And there was a post on Twitter that you found interesting, which was I'll read it out for those of you who are just listening. But there was a post.
Before you read it out, actually, you should probably give a little bit of context about Free the Sandbox. Because this was technically in response to Free the Sandbox, which is... I'll try and bring it up here, actually.
From what I understand, the guy is basically trying to get, like, Apple and stuff like that to try to open up phones to be more accessible to researchers.
Researchers and just endpoint security and things like that. So it mentions on their website here, I've just pulled up freethesandbox.org. You know, it's time to free the sandbox. Did you know that you are not allowed to independently evaluate the integrity of your own iPhone and Android devices? Goes into some of the challenges about needing to basically hack your phone if you want to gain access to anything. So despite the name being Free the Sandbox, it's not against like application sandboxing and stuff, but it is kind of about giving the end user more control over their device if they want to analyze it or look into it more. Which brings us up to this Chris R, I'm not going to say his last name, post there. I have to disagree with this. The security architecture on Android iOS absolutely cuts down on endpoint security visibility, but that trade-off results in a lot less malware and attacks in the first place. Mobile security was largely a success relative to the state of the desktop. And this definitely prompted a pretty significant discussion with at least a handful of names that I definitely recognize in there. So, I mean, you can read that. We'll have the link in the description as usual. But I mean, that key point, mobile phones compared to desktop, like if, 15 years ago, and this is, I'm quoting one of the reply tweets, if 15 years ago someone had predicted we'd see 1 billion computers with trusted boot, app signing, full disk encryption, mandatory access control, I'd call them mad. I think that kind of pulls up. Yeah, that was by this Andrew Drequith. I think that kind of hits one of the key points. Phones have a ton of security, and a lot of that is enabled by default. Can't really be turned off. You can't be tricked into turning it off. I mean, it's one of those things that phones are basically a second chance to get security right on the devices. It does cut down on what we can do, and people have complained about having devices that limit what you can do for a long time. I mean, consoles are a perfect example of that. But even, people complained about GPS devices back in the day and stuff too. So we've always kind of complained when they restrict power users, but when we're talking just about the security aspect, I think it's a net benefit. I mean, as much as, I guess I'll just go into my position here, but as much as I kind of hate mobile security in the sense that it takes away kind of the power user's ability to do anything, I mean, I would like to have access to the entire file system and not just have things kind of arbitrarily hidden without needing to remove my phone. But it definitely works by not having the incentive or the temptation to do that. There's no way that you're going to have your average person just accidentally be encouraged to, reduce the security of their device. And pretty much no matter what we do, the security will be reduced. And to be fair to the Free the Sandbox crew, mostly what they're asking for is some sort of way just to get a read-only file system access and memory dump. There's some fair suggestions kind of throughout the Twitter thread here. One of them from GrugQ. I don't know if I'm saying his name right. Definitely familiar with the name though. He mentions that he would be super happy with a freeze device memory, dump it via hardware access and pin access, and then a required hard boot after it. But like I said, like that doesn't sound too bad. But imagine, a very high value target. You pickpocket the phone, you've got your hardware access, have a single exploit to deal with the pin. Obviously, you need some sort of ODA, but it's not that unheard of to have pin bypasses. Dump it, reboot, and put pocket back the phone. The worst sell thing is, my phone rebooted. That's a bit weird, but it's not exactly abnormal either. At least my Android has, on occasion, locked up and done that. I don't know about iOS.
It's because I
actively used one. Yes, I'm sure that's what you were doing. I'm on airplane mode in the middle of random location in Montana. My phone locks off. I have no internet access, but you're hacking me.
Absolutely.
But I mean, I like the idea of opening up the device, but when we're just considering security, it is opening up some significant holes if you have this sort of offer. Maybe there is a solution to that. I don't know it at this point. I'm not sure what's kind of been suggested is really the best option, unless I had more confidence in kind of the pin systems.
So I've seen arguments for both sides. I will say mobile security, like you were saying, like with a second chance to get it right, I think they definitely hit it. Sandboxing on phones is very strong. It's definitely the strongest of any device, honestly. Mobile security is pretty much the top of the industry, especially Apple. They're kind of been the leaders on that. And
it's been quick to update too.
Yeah,
or at least quicker than desktop.
And updates are like, they're a lot more streamlined. And because you don't have to deal with like a bunch of different drivers and stuff, right? Apple, especially like with Apple, most notably, they have like all the control over the environment, which some people don't like. But because of that, they're able to push some of those security features forward faster because they don't have to worry about compatibility issues with a bunch of other shit, right? But I will say that there is something to be said for researchers not having researchers not having access to the device, because it kind of sucks that researchers have to hoard 0 days if they want to maintain access to continue doing research on a device. I think that's dumb. Because it's kind of the opposite. Like, if you want to be an ethical security researcher and find bugs and report them to Apple, if you want to continue doing that, you're going to have to purposefully non-disclose a 0 day, even if you want to. That's one thing that I think is worth considering. And
yeah, well, it's not only that. So when it comes to the forensics and like incident response, you're going to want that access of this device to pull out, what was the, file uploaded in the WhatsApp case. What was that MP4? You're going to want to see what malware was installed. In terms of having persistence on phone, once you've broken in there, because it is so difficult to get that intelligence about what's going on the phone, it's a lot easier for them to kind of hide and remain undetected on the phone. So it is a trade-off between either allowing there to be the compromises in the first place, because if you open up some system for it, people are going to abuse it. I mean, there's the whole self-XSS thing where people are told, go paste this JavaScript into, hit F12 and paste this JavaScript in there. Like, things that people really shouldn't do, and you think they'd be smart enough not to, and yet, oh, sure, I'll do that and have their accounts compromised on that basis.
I mean, one person that I've seen have a strong opinion on this in the past is QWERTY. A lot of you probably have heard of him. He's obviously pretty big in the iOS scene, as well as the PS4 scene. but like his opinion on it is like a lot of his problem with a lot of the newer like mitigations and stuff for phones and like the lockdown nature of it is it's easier to prevent jailbreaking, but it's not necessarily easier to prevent like nation state level malware. So like they're preventing people from customizing the phone or researchers from getting into the phone, but the people who actually matter, nation state attackers and stuff like that, they're not really getting affected as heavily. So
No, they're
his
not.
like argument is like, you know, it's not really worth the trade-off because of that fact.
Yeah, I don't know if I quite agree. So I'll be honest, I'm not going to come down hard on that because it's not like a bad argument. Like that is a very good point. That said, most people aren't being targeted by nation state actors. Most people, the average, ransomware and all that well, maybe some of it is nation state, maybe North Korea is trying to raise funds that way. But in general, a lot of your attacks are those lower level, easier things to pull off. Less technical, or just, spreading some random malware. And I think that kind of should be considered too. The average person doesn't need protection just from nation states. They're going to need the protection from, your everyday script kiddie attacker going around.
I mean,
so yeah, it doesn't stop the nation state attacker. But is that the concern versus opening it up for like the masses to be attacked? Like,
well, I think part of what it is with that too is like with nation state level malware, if you're going to be hit with it regardless, at least you want the ability to be able to detect it easier. Whereas with the lockdown environment with Apple, not only is it like not much harder for nation state level malware to hit you, it's a lot harder for you to know that you've been hit with it.
Yeah, well, that's kind of one of the things I was talking about, but when it came to kind of having the persistence. But one of the things to kind of consider of that is, I've actually just kind of lost what I was going to say there. Sorry. But I mean, I'm not against having like some sort of opt-in and out system. It needs to be significantly visible. One of those things like Chrome devices, like the Chromebooks, when you put into developer mode, would like wipe some information when you did that, and was very obvious and couldn't be used to get information that was on the phone beforehand. Maybe some type of system like that in order to allow it could be okay, but that's not going to give the incident response information. So that's not a perfect solution. But it would at least be a very obvious way to know it's been done or something's been done. Oh no, because Google has like their advanced protection on their Gmail, well, their Google accounts in general, which adds security. So I'm wondering if some sort of even opt-in to more security. If you're going to be targeted by nation states, you're probably kind of aware of that fact. Maybe not, but a lot of people are going to be aware of that fact and can opt in to further security. I don't know, just having the option there though is going to weaken the absolute security. Or like, yeah, I mean, I don't come down hard on either side of this. I haven't spent a lot of time considering it. Sure. Yeah, I mean, Cordy's point's definitely valid.
Yeah.
Like I don't disagree. I don't necessarily agree though either.
I mean, I kind of like the Android approach where you can enable the developer mode by hitting the build number a certain, like 5 times or whatever it was.
Yeah, but that doesn't give the access that you need though for IR and stuff. No. That's like, it's getting there, like fine, but you can go take anybody's phone and go tap developer a few times. Like that's not really much of a security thing.
Yeah, I mean, one solution that I've kind of thought of while we were talking about this is I don't know why Apple doesn't just sell, or like, well, any phone company doesn't just sell developer phone models that are just for researchers and stuff like that. Obviously, that doesn't tackle the malware issue of doing like forensics on it, but at least on the researcher angle, they have a device they can work with that's purposefully left open that consumers aren't going to buy.
That sounds a little bit like, developer consoles and stuff, where they're similar, but they're going to be different. Just necessarily things are going to be different across them.
You're right. There were some system differences too, so that is worth noting. Yeah.
So I don't know if that's really going to be an effective solution. It wouldn't necessarily be a bad solution to see that. That said, I mean, at least Android does provide, like, kernel code and stuff.
Yeah.
So you're able to kind of load that up on your own, like, VM or something to work with. So at least if you want to assess that level, and then, but of course you do have all the OEMs kind of doing all their custom loaders and whatever else on there.
Yeah, Android's kind of a mess when it comes to source code, but that's an issue for another day. So getting into some exploits, there were some more MDS attacks. I think it's LIDES and VRS. I think that's how you say. Is that how you say LIDES or L1
I would just
VS?
say, I would just say level 1 data eviction sampling. And
Okay.
it's so basically we've talked about MDS attacks before. This is your Fallout, your Zombieload, and Riddle. I think were kind of the three main ones with that. This is the stuff where Intel, like basically the Intel CPU stuff you've been hearing about. Basically over the last, like, what's it been, like 18 months? Maybe longer?
Feels like longer.
Yeah, and we keep kind of getting these little updates, like Intel patches all these findings. A few months later, oh, actually, we knew about these other issues, we just didn't patch them. A few months later, oh, we also knew about these ones, but we just didn't patch them yet. And now we're on our third patch of the patch of the patch. Oh, where we've got the L1 and your vector register sampling. If you want to kind of know more about the general attacks, it's the rogue in-flight data load. If you're familiar with Meltdown already, Meltdown also had the name Rogue Cache Data Load. So kind of similar concepts going on here, but we talked about this in reasonable depth back in episode 10 when MDS Attacks first kind of came out, and Zombieload at the same time. And then we had a brief discussion kind of on episode 18 also. I'd kind of recommend you go there to get the idea of what the attacks look like. These two are just variants of the Riddle stuff, where they found that basically the patch either wasn't effective. I think the L1 cache, their patch just wasn't effective, and you can still load information. And the vector register sampling, that one's a little bit more interesting just because it lets you leak a register value. So, it never hits memory and you're still able to leak it. But these are just variants of the same thing. These dropped this morning, basically. Intel put out their not their usual advisory. They had a blog post. I think there's an advisory, but they haven't patched these yet. They hit kind of the end of the embargo period. And as they said, they've, in the interest of transparency, they're making it public. Okay. This is I just pulled up their blog post here. And yeah, due to their commitment to transparency, the advisory has been released before planned mitigations. I kind of scoff at that, just given how Intel has handled this. These have been disclosed a while ago, and they're still not so sure, but they also had these added embargoes on a lot of these issues. So I haven't been able to confirm the date. Apparently one of these was reported really early on, like right at the beginning. I believe that was the L1 cache, and then Intel kind of ignored it. And so the MDS team kind of went forward and proved that it was an actual issue. I don't have a proper confirmation on that 18-month date, so please don't quote me on that, but I believe they've known about it for a good chunk of time beyond just the proof of concept being provided back in October. I think the Zombieload team found that one first, actually, and had it, I want to say May, but I because this just dropped this morning, I wasn't able to go through and get all the dates for everything. But it seems like this might have been known for a little while and just either ignored or missed by Intel. I believe they say that they just missed it at one point.
So I'll be honest, we definitely wanted to cover this because it is news that happened, and it is something that we've talked a little bit about before. But I am starting to get really tired of like all these Intel issues that just keep coming up, man. It's like every couple months, it's like whack-a-mole.
Yeah, so
Like,
there's one fun thing actually that they did with this update. It's not related to a new technique, but they've been optimizing their riddle examples. I guess they're actually using this in their secure hardware or hardware security master's level class at VU. I'm not actually sure. So one of their students actually has managed to leak Etsy's shadow in just 4 seconds. If I recall, when we were looking at having some of these files leaked back when this was first announced, I want to say this took like a day or something to do.
it was less practical, definitely.
Yeah,
I know we
so
talked about that.
there's this YouTube video here. I mean, I can basically just go ahead and play it with them leaking Etsy shadow in. Well, there we go. It's done already. It's the video here is 9 seconds, but they say it can get the password down in 4 seconds. So they've done some optimization there. They just put that video out today, but it's not, strictly speaking, a new attack.
Okay, that is pretty interesting though. I didn't see that when I was looking over the page quickly. So
I thought it was kind of just a fun addition. But yeah, if you want more information on the attacks itself, look at episode 10. We kind of talk in, or just look it up on YouTube. There are some really good videos that go in depth about what's going on with in-flight data loads.
Yeah. So CyberMDX, the CyberMDX research team discovered a vulnerability in GE Carescape, Apex Pro, and Clinical Information Center systems. So these systems seem to be like healthcare related systems, right? So they talk about CIC Pro, Clinical Information Center Pro, and it's used to view like patient data and monitoring, setting like alarm limits, patient administration, all that kind of stuff.
So I mean, these devices are like your care devices, like your blood pressure, pulse temperature, blood oxygen monitors, like kind of that standalone. Like if you ever, you're in the hospital, they take your blood pressure. They've probably, maybe not this brand, but it's that type of monitor is one of the devices that impacted. And then their telemetry systems. So where the data is getting sent to, that's what the Clinical Information Center system and the Apex Pro stuff. Their telemetry systems are also impacted by this.
Yeah, physiological data. So they were saying like there was quite a few issues they found in like all these systems. One of them was they detected like a number of the devices were running with open ports with deprecated webmin versions. Enough said there. I think people could probably figure out why that could be an issue. They're very outdated.
Well, yeah, I mean, not just outdated webmin. This is like 2005 webmin.
Yeah, deprecated. Yeah. And then they found an issue where there was a private SSH key was shared universally across all devices.
Not just shared, it's on the device. So they don't just have the public key there. They have the private key included on the device for some reason. So having SSH isn't that crazy. And one thing just to mention here is this has kind of been dubbed in a few places MDHex.
Okay.
Yeah,
MDHex.
in terms of the attacks, the MDHex vulnerabilities. I don't think the CyberMDX has actually used that, but I have seen that name kind of go around a bit. As Spectre was just mentioning, though, the SSH isn't necessarily that unheard of, especially when you're talking about like the telemetry system. People might, mostly like technicians and stuff, might need to SSH into it. Hopefully this isn't on the internet. It's probably listening just to the network, which if the network's on the internet, then could be listening out. More likely, though, this is kind of just a local network thing.
I was thinking that too, yeah.
I mean, it could be out to the internet, but I'd imagine most setups, because a lot of these devices, it is common for them to be listening out to the network, and then it's just on like their own private network. And usually, because of HIPAA and stuff, like they do have some reasonable security around the network. But yeah, so technician might come in like SSH in, or they have as we mentioned, the private key sitting on the server for, as far as they're aware, like no reason. There's no reason to have the private key used to connect to the device on the device. You can have its public key. That's all you really need.
At the same time, though, it is worth mentioning that is a fairly high condition to meet to exploit it. Like, you do need one of these devices to be able to pull that key, unless somebody who has a device already puts the key up somewhere. Like, if you want to pull the key, you're going to need one of the devices with that key on it.
If you're
And
targeting
gonna
medical
need-
devices, though, it's not necessarily that hard to get your hands on some things, especially since it is universally the same.
Okay.
Across the lines, at least.
And obviously, on top of that, you also need the local network access, most likely, like you were saying.
Yeah, which may or may
is,
not be hard. I mean, so usually, like, I don't have a ton of experience with hospital networks, but a lot of them will lock down the ports, so it's only like known devices that are already connected. And if something new comes on, it's a problem. I can't say that's going to be everywhere, but that's been my experience. Is that you can't just go hard plug in and just get access to everything. I'm sure there are a lot of hospitals that just aren't secure though too, and it's just a bias from what I've seen. That said, other issues though from this, since you mentioned actually getting the key, is there's the SMB or Samba. So you're able to get access to, or it's hard-coded credentials basically across the entire line of devices. Hard-code creds, and those creds are available in product documentation, which is available online.
I found very interesting. I don't know why they have creds in documentation. That's kind of a
so hard-coded creds. I mean, like, I'm sure you've seen other documentation with that. I'm not saying it's a good thing, but
with like default creds, sure.
Yeah,
but
well, I imagine that's kind of what's going on with this one.
Yeah, it's probably something like that. They didn't say it was default, but I imagine.
If it's in the documentation, I have to assume it's both default or even just not really something you can easily change.
Yeah, it could be.
Let's say it also mentions that creds can be obtained. Or I'm sorry, I misspoke there. The creds for the SMB share are actually not publicly available, but you can get them right off the device by doing they mentioned by performing a password recovery on the Windows XP embedded OS. I'm not entirely sure what the password recovery mechanism is there, or if they're just referring to, extract the SAM file and recover the password that way, or brute force or something like that. So my apologies, I did misspeak there. It's the VNC, another thing they have out open to connect to. The credentials to VNC, which is basically like screen sharing type stuff, like see the screen, control the computer. Those are publicly available and in the product documentation.
Easy to mix up. It's basically the same issue, just in a different area. So
yeah. In terms of what isn't the same issue though, is the multi-mouse and Kavoom VM vulnerability.
KM.
Keyboard mouse. Which is essentially, a system to allow a single keyboard and mouse to control several devices. It also seems to be networked, so they don't give a lot of details on what this actual vulnerability is, but they do assign it.
Was no credentials.
So that's what they give it the CWE 306, which is missing authentication for critical function. So I'm assuming, somebody can basically just get on the network and start sending keys and moving the mouse and stuff. Like, it doesn't authenticate or like that it's coming from the legitimate location. That's kind of my assumption. They're not clear about that. It just says, the integrated service for keyboard switching of the affected devices could allow an attacker to obtain remote keyboard input access without authentication over the network.
Which I think is one of the more serious issues. Just because, if you... it does seem... I could see that attack being pulled off more than some of the other ones we've talked about.
Well, I'd see that as almost the same as like VNC, though. And passwords, publicly known, it's not all that difficult. The SSH key, I mean, you were mentioning kind of the high barrier for getting that key file. I don't disagree, but I feel like because it is across a lot of product lines, I don't know if they mention exactly if the same key is shared across the product lines or if each kind of product shares the same key across its own lines. But nonetheless, I mean, go on eBay, you can find devices. I mean, it's probably been used for quite a while, so you can find just an older device to use. And the last vulnerability that we haven't talked about yet is the update management vulnerability, where some devices will just, accept whatever update you send it. Others, you need a, SSH in first, using the key that we already know is shared across everything. And this is the only one that the actual monitors that I was talking about at the beginning, the like blood pressure monitor and stuff, I believe this is the only one that those were impacted by. The rest were all of the telemetry based systems.
Yeah, the patient side monitors. So there was one thing, like now that you've talked about all the issues, there was one thing that I noticed that really had me scratching my head. Was they had a quote that said, "GE Healthcare plans to provide patches and additional security information about this vulnerability for users," and the key words "plans to" kind of stood out to me. So they put this information's out there, and it seems like it's not patched yet. And I guess my question is why? Like, I don't know, man.
Yeah, I don't know. I'm looking. They do have a link here to their disclosure of it.
Yeah, so I mean, it's been disclosed by the company itself. It's not like
yeah, it still says that they're
yeah, they're still doing updates. So they're not out yet.
You've got to
so
log in for that.
Like, why would they, like, if it was a deadline thing, why wouldn't they ask for an extension? Like, I'm just like, why would they put out all this technical information about these attacks if there's nothing on, like, if they're not finished patching them yet? It just seems weird to me.
I mean, so this is out by MDHex. Like, a lot of the details here are from MDHex who found it.
Yeah.
Or Cyber MDHex, I should say, and not necessarily the advisory from GE. So that could be why, because I don't think the GE advisory was really as in-depth here at all.
Well, there also was an advisory put out by Homeland Security that I saw. And theirs wasn't as in depth, but it did have, like, I think the CVEs and stuff like that. So there was a little bit of technical information. But it's like, I'm not trying to call out Cyber MDX here. I'm not saying they had any, like, malicious intent. It's just one of those cases where I think it should have been delayed until patches were done.
So,
especially
I guess,
in something like healthcare, right?
Looking at the CISA page there, looks like GE recommends users confirm the proper configuration of the MC and IX network. So it's basically, saying what I said. A lot of the networks are going to be fairly locked down for people to actually get this level of access. And it does mention here, like, there are the clear mitigations that are probably, they do mention management best practices that should be followed. Like I said, because of HIPAA and stuff, my experience has been a lot of hospitals, at least at that level, like, there are a lot of other issues that seem to pop up in hospitals, but this is the locking down the networks, kind of one of the easier things to get done. And it's one of those compliance checks too, I believe. So I feel like, the mitigations here are probably sufficient. Like, they have a way to prevent this from being attacked, basically.
Okay. I mean, yeah, I still think it should have been delayed a bit more, but that was something I wanted to know, because, like, that kind of jumped out at me, right?
Yeah, it's a fair point.
Yeah. So JSSE, Java stuff. We love talking about Java.
Before we jump there, maybe you'll want to there, but in chat we have the question: is OpenBSD safe? What do you think?
Very, very loaded question. No. Because remember, we had those, like, 2 episodes where we covered, like, probably, like, 4 or 5, like, root
some significant OpenBSD vulnerabilities.
LPEs,
or what did you call it?
Wide
open BSD.
Yeah, that was the nickname for it. So yeah,
and that was episode 21 and 22. We talked about some OpenBSD stuff, kind of back to back there.
Yeah. So back to JSSE. So these guys.
Although before we do that, sorry, I do want to mention for myself with OpenBSD. I want to say OpenBSD at least tries on the security front and has updates. Is it safe? No. Is any operating system safe? Maybe. I don't want to make a universal claim, but generally speaking, any operating system you're going to use probably is not safe. Does that mean there's never going to be, like, some super simple operating system that is, at least at the OS level, safe? No, I mean, there very well might be. Is the hardware safe? Then maybe not, but, as we've seen all these Intel issues. That said, I mean, OpenBSD isn't a bad choice, but I believe, OpenBSD isn't a easy choice if you're going to use it for something that's being given out versus, like, FreeBSD, which has a much more permissive license.
Yeah. We just need to wait for the first Rust-based operating system to have the truly safe OS.
Of course, yeah.
Yeah.
There's never any security. I mean, well, as soon as you include a Rust library, I mean, the entire application becomes secure.
Very true. We just need some Rust kernel drivers, and then it's over, man.
That said, so bin, yeah, I don't know, but if you want to kind of specify more on what you're asking, like is OpenBSD safe in some specific way, we can maybe answer a little bit more. But just asking, is it safe? You kind of just gotta give the safe answer as no.
So
So getting back to JSSE.
Yeah.
And I'll just cut you off since I'm going to be talking about this one anyhow.
Fair enough.
If you're not familiar with it, I mean, a lot of us are going to be familiar with TLS. That's basically your encryption. Your HTTPS is hopefully using TLS by this point. You shouldn't be using SSL v3 or older. Should be on TLS by now. I'm sure people still are on SSL, but anyway. With that, there is also an option for the server to ask the client to go and send a certificate to be used to authenticate the client that's trying to log in, like to basically do login over at the TLS level. And I mean, it's pretty simple. Just the server will say, like, after the initial client hello, server hello, like in the server hello, that same packet going out, it's going to include a message saying, like, provide the client certificate, or certificate request message is what it includes. Then, of course, the client sees that, sends its certificate along, does the client key exchange, which is, either the secret encrypted with like the server's public key or the ephemeral public key if you're doing Diffie-Hellman. Client then also adds in its certificate verify, so just to prove that it has the private key, it'll sign its own handshake. And then it does, the usual change cipher spec and finish message. So that's kind of your normal flow. Kind of what this one discovered is if you mess with that flow a bit, so with DTLS, so you're like TLS over datagrams or UDP based, it has a bit more of a relaxed flow in terms of what information you can send along, and the packets can be received out of order. So they're able to kind of mess with its internal state tracking and have it authenticate you even if you don't provide a valid authentication. So that actually there's two exploits based around that. First one, I'll find it on here. First one, essentially, you get kind of the normal client hello, then the server message does its thing, asks for the certificate request, and then all the client does is, instead of sending like its certificate, it just goes, okay, here's the client key exchange, change cipher spec, and finished. Which is the normal flow for not having a certificate at all. So it basically just ignores the certificate request. And what happens is, if you're running the TLS and JSSE on, so you can kind of run it under a couple different modes, either required where you must provide a certificate, or wanted where you can provide one, but you can go ahead and, if you don't have a certificate, just send an empty cert and it'll give you like a warning page or something. So that's probably more common, I'd say, to see being used. That way you can give an error like, hey, you should probably plug in your smart card so the site works instead of just having the connection terminated. But these bugs work when it's in required mode. Kind of mentions there with client authentication set to required. So anyway, by doing this, just ignoring the whole request for the certificate, it sees the client key exchange and it's like, okay, I'm now expecting a change cipher spec and finished. Gets that, so it's like, hey, we're done. Let's just carry on, and it pretends that you actually did authenticate. Now you might be wondering, well, who did it authenticate as? Nobody. If the server actually tries to go and check, like, what certificate was actually sent to me, it'll basically have a null dereference because no certificate was out. It'll give a nicer error, but the gist of it is it's null, so nobody actually authenticated, but it will let you pass through when it's sent to required. So that's kind of the first exploit. The second one's a little bit more complicated to understand why it happens, or exactly why things are done in this order. But what it will do, again, the server does its normal thing, asking for the certificate request. And what'll happen is that it does the same thing as before, where it sends the client key exchange, change cipher spec. But then instead of sending finish, it goes and sends the certificate in there, and then it sends finished. Then it does a change cipher spec and finished again. Which seems a little bit weird, but that's kind of messing with the internal state tracking. So what ends up happening is, first of all, as per the first exploit, when JSSE sees the first change cipher spec, it's expecting that the next message will be encrypted using, all the proper keys. Obviously, you did the client key exchange right before that, which is where kind of your keys are established, essentially. So it does that, and the certificate is encrypted in that way. So basically, when JSSE is looking, it's seeing like, oh, hey, I got this encrypted message. Kind of checks the box saying, okay, that state's been passed. It looks at it, sees, oh, this isn't finished, so let's revert a little bit, and the certificate just gets buffered, as though we're sent maybe later. So then JSSE sees the finished packet, or sees the finished message. These are all kind of in one pack. Well, things can be fragmented and all of that, but it's kind of looking at it as a group. So it sees the finish now, so it's like, okay, hey, we're finished. I'm not expecting a finish, though, anymore. Because it already had that little encrypted check. It sees the finished, and it thinks that this finish is just out of place. It actually wants, because it's a certificate, it's actually waiting for, or it'll respond now to the change cipher spec. And then you send the finish again. And it lets you authenticate with any certificate you can provide without actually providing any certificate verification. So that's your second way through, and that just has to do with being able to send parts of the packet out of order, so it kind of sees something, and so that's only really impacting your datagram TLS, which isn't terribly common. I can't think of a time I've actually seen it. Maybe some games have used it, but
I was going to be honest, I hadn't really heard much of DTLS before seeing this article. It's not common, I guess.
No, definitely not. TLS is obviously a lot more common.
Yeah. Sure.
That said, there's a very similar vulnerability with TLS, where basically you just send the certificate you send the certificate, you send the client key exchange, change cipher spec, and finish. So you send the certificate first. Actually, I think you're supposed to send certificate first. My bad. Yeah. So you basically just ignore the the certificate verify, and it's totally fine with that.
Okay.
So that one's a little bit easier to get, and it lets you authenticate with that certificate without actually verifying it. So, yay.
Awesome. I found a few things of interest just when you were scrolling through there. One thing, I did see a Baby Yoda meme. I'm going to have to take a few points off the article for that. I think that meme's kind of dead. We got to... Yeah, we got to take those out of the internet now. The other thing was I found it kind of funny. They gave an overview of DTLS at the beginning of the article, and they described it as the crayon eating brother of TLS. So
yeah,
I thought that was pretty funny.
Well, I mean, it's definitely you can see the similarities between just TLS and needing to do it over datagram, but because it's over datagram, there's so many things that are just kind of loosened in terms of restrictions that kind of create these. Yeah. Oh. But I mean, it is the reason why I said maybe it's used at some games is because games like to do more of the datagram based stuff. Just you don't have to deal with a lot of the TCP
Definitely.
stack. You don't have to deal with a lot of things that can cause slowdowns. So that's what I can imagine. And I think one of the first places I really saw DTLS explained to me was in a game development blog. I don't remember for sure if that's what it was, but that's where I think it was. That's at least kind of what I remember.
Yeah, I remember I was asking you a little bit about it, and you said that you saw that game development blog one a while back, but you couldn't find it anymore. So I was SOL on that.
Yeah, and I'll be honest there, their explanation isn't terrible, but it's dense. Yeah, the whole thing,
They don't have any paragraph breaks, man. It was kind of hard to read.
There's a paragraph break right here.
I know. Okay, sorry.
But no, I mean it's
little.
very it's a very dense read. There are definitely better options to kind of get the gist of that. And if you understand kind of what TLS looks like, then there are examples here about kind of how they mess with the order and stuff. Just looking at that as usual is sufficient to kind of understand what's going on here. I wouldn't necessarily go look here for their explanation of DTLS though.
So
again, they cover what's needed though. Like, in fairness, they do give you the appropriate background. It's just, as we said, very dense.
Yeah. So, as they say, the TLDR there is if you're using TLS client auth in Java 11 or newer, patch. So, yeah. So, there was also a post put out by Pentagrid about local privilege escalation and many Ricoh printer drivers for Windows. So, Z, do you want to take this one away? Because I somehow skipped this one over when I was in my notes, and I have no idea how. But
yeah, and I mean, this is just another stupid DLL permission. We've covered more than one of this sort of issue. The simple premise here is you install a new printer. Where's the technical details? When you install the new printer, it's installing by default into program data /Ricoh_DRV. Like during the printer setup, and normal users can add a printer. So it doesn't take any special privileges. It might at some point, but it does mention here explicitly, it's in standard install adding a printer doesn't take any sort of admin account. So it pulls the driver into the program data Ricoh driver folder. And it has some deeper folders in there where it then has several DLLs that just inherit their permissions. And that's inheriting out of program data. Globally writable. Everybody can overwrite any of these DLLs that are included in at least one of the folders.
So just another DLL hijack attack.
Yeah, overwrite here. Yeah. Overwrite the DLL. So you do have to time it, actually. You do have to time the DLL. That is kind of one of the main preconditions, and you do need to be able to install the driver. So it's possible in some cases, but if it is more locked down, if you're on an enterprise version or something, or just having the group policy, it is a little bit more locked down. But you can do it in a lot of cases. But yeah, it's basically overwriting the DLL at the right time. There is kind of that little condition. It needs to be kind of after, basically when library code, yeah, so I'm pretty sure it mentions a bit more detail there, but I don't see it on the page right now. But there is kind of a key point to do the overwrite so that it gets loaded appropriately. But, okay. I mean, it's world writable, so no real protection. We've seen this sort of issue before. I just thought I'd mention it because
like QT desktop stuff had a similar issue, I think.
Well, so QT, you could provide that. That was the bug where you could provide a flag to it to give it the location to drive. No, I'm thinking of an antivirus. One of the antivirus things we've covered did something really similar.
Which is not surprising at all. Yeah. So,
it's a common issue.
Yeah. So Spider Labs did a post. By the way, I love that name, Spider Labs. That's an A+ right there. And the title is ModSecurity Denial of Service Details, CVE 2019-19-886. I got tripped up a little bit there.
I'm going to test you on that number.
Okay. So yeah, they talk about an open source firewall called ModSecurity. And
this is popular. Firewall. I mean, a lot of places use ModSecurity. ModSecurity is probably one of the more common web application firewalls that I've seen.
Yeah. So basically, gist of the issue, from what I could tell, was that a pull request was made to address cookie parsing. There was some kind of issue in it that somebody wanted to address, and they ended up introducing a vulnerability that would cause the worker thread to crash because you could trigger an out-of-range exception. So if you can cause worker threads to crash, if you just flood requests that crash the worker threads,
well, so I do want to talk a little bit more about what the actual exploit is, because it's super simple.
Fair
It's
enough.
in the cookies, as I said, in the processing. And this is discovered actually looking at the regression test and to look at differences between ModSecurity 2 and ModSecurity 3, which is kind of where that ended up being discovered. But anyway, all it is, and I'm sorry for those of you who are only listening, I'm putting this in chat, but you literally just send a cookie header with an equal sign and a semicolon. That's it. That's all that should be in your cookie header. If you send that, it'll kill a worker process. So then you do that in the loop to kind of do a continued denial of service against all of the responding processes. But it's basically having a cookie without a name. It didn't work if you did a semicolon equals semicolon, so it had to be kind of the first cookie that didn't have any sort of name.
Okay.
I'm not sure if it would work if you had anything more after the semicolon, but at least when it parsed that first cookie, it would end up failing there and going out of bounds and getting that crash.
Okay, yeah, that's a good ad. Thank you.
But really simple issue there. Like, you could see this being done. This is going to get scripted up pretty quickly.
Yeah. I mean, I kind of liked this blog post just because it's kind of cool to see it happen in open source, just because you get more of a idea of like the behind the scenes logistics of what's happening. Like how easy it is to introduce a silly bug like that, and then what goes into like addressing it and patching it and stuff like that. I thought that was kind of cool because a lot of the stuff we talk about, we can't really, we can tell you what's on the page, but we can't go much more into that because it's closed source. We don't know much about like the internals of what happened with patching it. But
yeah, we don't want to do any patch diffing before these episodes.
Yeah. So, where this is all open source, I thought that was kind of something that I don't think we've really covered much before. If we have, it's like once or twice.
Yeah,
it's not something we get to see often.
I appreciate the fact that they've covered, and I mean, we have done open source before. Like, we have talked about the Firefox stuff, where we just didn't want to get into the patch diffing. I do appreciate that they include kind of the discussion about kind of the discovery of the bug and kind of the not necessarily thought process, but they do include information about like the regression case and why that test case was there and what happened when it failed ModSecurity 3 versus 2. Yeah, I mean, it's a good post.
Sorry, I just want to correct myself there. I meant open source project that's like not like a browser or something that's like, probably like it's a code.
Yeah, we do talk about a lot of closed source stuff.
Yeah, we do. But like even some of the open source stuff we talk about, there is like it is such a complex code base that it is a bit harder even though it is open source, to like dig into it. This one I think is, it's you got that story behind the bug, and I think it was just it was kind of cool. I thought it was interesting because it's not something we get to see too often. So GGvulnz, there was a post put out about how I hacked hundreds of companies through Google Groups. So another stupid issue that popped up during the week, and it's essentially just using companies' public mailing lists to register for services. That's pretty much the gist of the issue.
Yeah, I mean, so you do need read access. Although what they found is Google's aware of misconfiguration that allows searching of messages even if you don't have read access to the list, which can be used. But yeah, I mean, you gave it the exact summary. You're just signing up using like a mailing list. So if you want to sign up for Slack and get access to certain organizations, then you need to have an email with their domain. So that's where using their mailing list kind of comes in. So you get the company, if they have some sort of public mailing list, either just publicly readable or something that you can actually join, but just something that'll give you an email that you can read that belongs to that company or has whatever domain that's being looked for.
Yeah. So there was a lot of drama around that. Well, not a lot, but there was a bit of drama around this. If we, go down to some of the conclusions of the article, they were talking about Google. They reported this issue to Google, and Google was basically, the meme won't fix. They stated they won't fix it because it's intended behavior and it's not on the fault of Google if the company exposes its mailing lists in an improper fashion. It's basically the gist of what Google said there. And basically, like, the way this guy puts it as a quote is basically everyone was blaming the users for having a publicly readable email box. My thoughts on that, I don't really know what other response he expected. I think that's actually, I don't think it's reasonable to expect Google to, like the one you were talking about where you could potentially search without read access. I think that would be reasonable to expect Google to fix.
Yeah, but
like,
it is a misconfiguration that results in that. It's not necessarily, it's not like a bug. It is a configuration related.
Okay, so like it's one of those things where it's like if you misconfigured it so that your public mailing service is publicly readable when it shouldn't be, like that's on you.
I mean, the thing is, mailing lists are often public. What are you going to have Google do? No longer allow public mailing lists? I mean, that's...
And then even if Google doesn't, there's going to be other companies that do. So it's like, it's not really...
Well, I mean, some mailing... Like, I'm on several mailing lists that are... I mean, some of them are security related, some aren't, but you don't just, like... The whole point that it's open, anybody can just join and start being on this whole mailing chain is kind of the point of a lot of them.
Yeah.
So, I mean, it is... the reason why I actually want to talk about this, though, is just I thought it was still kind of a neat vector to get the email address. I mean, it's mostly kind of, if you'd use that, like, if you're pen testing or something, so it's not something that I would necessarily report too often because I'm not, like, testing, a company's Slack system or whatever, but, I mean, it's still kind of an interesting idea to do that, but in terms of fixing it, like, that's definitely not Google. I completely agree. That's on the company to lock down that sort of thing, or have a more locked down means of registering for, like, they use the example of Slack. You lock that down so accounts need to be created or needs to exist in AD. People don't just get to register.
Yeah. I mean, there's one part that I can kind of agree with, and that's that, I looked into some discussions talking about this because I was curious of what, like, general thoughts were around this, around the community. And one thing I can, like, stipulate is that Google's G Suite admin panel, it could be organized a lot better. It's probably not hard to do these misconfigurations just because of how annoying it is to navigate that panel. I can definitely see, like, some criticisms there of, like, it's too easy to misconfigure things. I think that would potentially be something.
I mean, that's definitely an issue with
Google.
Yeah, no, that's fair, and that's definitely an issue. And I mean, I hate having to use the admin panel for Google stuff.
Oh, it sucks.
Mostly because, I mean, one, I use Firefox and it is, like, so slow on Firefox. I mean, Chrome's all right, but Firefox goes very slow.
I wonder why.
Yeah, I mean, it's probably totally unrelated. I mean, certainly Google wouldn't have doing
making their browser faster on that. Yeah. But yeah,
I mean, it's just a complicated website. But no, your point about the configuration is, I think, spot on. It is easy to kind of make that mistake, but I think it's also, in a lot of cases, it's desirable. A support emailing list. Like, there's a lot of cases where you're going to have a public list, and it's just kind of that association of, oh, and over here, you also need to register, and we're using the same domain, kind of that, like, it's just something that maybe you don't think of because it isn't a direct connection.
Yeah. I mean, I don't want to shoot down the article. I think it's good for raising awareness on the issue, just because I can definitely see companies just overlooking it entirely, kind of like what you were saying, right? Like thinking, oh, we have a company Slack, but we also have a mailing list on the same domain, and it's sometimes you just don't put two and two together. I think it's good for raising awareness on that issue, but I think it is unreasonable to pin this on, like, Google or any company that's offering mailing list services.
This isn't just Google. This is going to be any sort of mailing list.
Yeah.
There are other options besides just Google Groups. I mean, Google Groups kind of gives you the nice search. There's a few different things with Google Groups in particular, but no, this is definitely, I think, on each company to configure securely or at least be aware of.
Yeah, but definitely a good article for raising awareness on that. So I think it should be shared around a little bit, and hopefully companies take note of it.
Or pen testers, just, be aware of it. You can definitely, I'm sure there are places where people come across to use that.
Yep. So keeping on the topic of stupid issues, there was another advisory posted for Neowise, CarbonFTP, and their summary was basically insecure proprietary password encryption. So
encryption. I say that with air quotes.
Yeah. So, this basically CarbonFTP, as you probably guessed, it basically allows you to sync local files with a remote server. But the problem is they rolled their own crypto, and we could probably just leave it there.
Yeah, well, so they rolled their own crypto in the sense of, so you're setting up your FTP and you enter, your domain, you enter your username, you enter your password, and then it will save the password for you, or it can be configured to save the password for you. And how do you save the password securely? Well, in their mind,
encrypted
they
with
start off
encryption.
Yeah, they start off with their not a random number. It's 18,508 though. Probably chosen to be random, but everything uses that. Or I'm sorry, I was looking at the wrong value here. They basically, use the value or add the value 200431. Kind of every 2 bytes, they're just adding that value to it. Yeah. As their means of encryption. They kind of show it down here as it looks there. You've got so that I read that 18,508. That was the 2 characters that they were using. So my mistake there, but essentially they're just adding values to obfuscate
it's kind of like
password.
A one-time pad, but they're using the same key for every byte.
Well, I wouldn't even, at least if it was XOR, I could see why they're thinking one-time pad, but with this, it is a common problem. Do you store it in plain text? Well, no. Okay, they don't want to store it in plain text. But this solution it's not a solution. It's a very minimal amount of obfuscation. And I mean, I'm sure FileZilla will do I'm going to assume it stores it in plain text. I'm purely speculating on that. But I mean, it's the user experience. Without entering a master key, there's no real way to store the passwords. But I think they should just take the master password, something like that, to actually encrypt the file, to actually encrypt that storage.
Yeah. One thing that I found kind of interesting was when they were breaking down how the bug worked, they found that longer passwords were actually easier to break because there were less potential candidates for the end password. So I just want to say, you fucked up when longer passwords result in worse security. That's kind of a fit. That's a point of critical failure, I think.
Although, as Divma said in chat, you tried. Gives them a little star. And I mean, that is they tried to do something here. It's just this is a completely useless thing to do because it's entirely trivial. And I mean, even if they did something more, even if they used AES with some key, the key is going to be in the software. It's going to be, and it's probably going to end up being static. I mean, there are some things they can maybe do better. Maybe they'd randomly generate a key, but the key's still going to be there. It's still going to be breakable.
Definitely.
I think really the only solution is a user provided key to encrypt it with. And that ruins kind of the user experience. But I really wish that would just be the default with all of these things that try and store your password for convenience. Just so when you start it up, you have to enter a password. It doesn't need to be insanely secure. It just having at least something real there that requires your thoughts. So your password isn't necessarily the most secure thing. Somebody can just take that file and they can brute force it in their own time. You use a strong password, then you're going to be more secure than if you use a short password. But then that's kind of more on the user choosing their password. So in this case, I mean, it's sure, they tried, but they didn't try very hard, and it doesn't do anything, basically.
If you absolutely didn't want to prompt user for a master password, you could at least do something use use a crypto that's common. There's a lot of crypto libraries out there. Let's just say AES, for example, or something like that. And then you can generate the key with some hardware unique identifier or something. Obviously, if anybody who can get that identifier can get the key, but it's at least a little bit harder to get to.
With that, I mean, you just use any sort of random source, any sort of random key, as long as somebody goes through the hassle of reverse engineering. And to be fair, it does take a little bit of a hassle. That will probably turn away some script kiddies from doing it. But as soon as one person's done it, and they go post on hack forums or something how to decrypt carbon FTP passwords, and now everybody's going to be able to add it, and it just does nothing. So I don't know. I mean, It's
Always
just
fun to
a
laugh at some bad
stupid
crypto,
thing.
though.
Yeah. But that's why I added. I mean, it's bad crypto, really bad crypto.
So jumping into some less high-level stuff and more low-level stuff, we have ARM64 uaccess, and this post is a commit on the Linux kernel mailing list, and it's titled "Ensure PAN is re-enabled after unhandled uaccess fault." So for those of you who don't know, PAN it stands for Privileged Access Never. We actually talked about this quite a lot on episode 24. Because there was a Sagusa blog post that was actually kind of similar to this in a way, with bypassing privileged access never, and this is another bug that can allow you to bypass it. So this bug basically subverts privileged access never, because they just didn't consider let me just go down to it. They didn't consider unhandled access faults in userland. So, an unhandled user access fault could occur, and then privileged access never could not be re-enabled, or it could be delayed before it's re-enabled. Now, this doesn't affect CPUs that have hardware support both for privileged access never and user access override.
Yeah, I do just want to jump in really quickly and make mention that what's going on here is an early exit issue. It's a common thing, but basically if it fails during it, after it turns it off there, and your copy and copy from copy to user functions and clear user, but if something happens there, has an early exit, so that happens because of the uaccess, the fault during the user access, it ends up exiting early and never goes through the process of re-enabling it. I just wanted to kind of point out what the core of the issue was, which is that early access, which we've seen before.
Yeah, and obviously that is not a hard condition to meet in an exploit at all. All you need to do is just mmap one page, put your data at the end of the page, and then call a size that's longer than your address plus the page size. So it'll end up overflowing into the next page, which is unmapped, which we'll call a page fault, and then you have the copy in or copy out or whatever, or the copy from user, copy to user, that'll exit out early, like you were just saying, and it won't re-enable PAN. So it's not a hard exploit to pull off, really, if you know a little bit about how memory works and how easy it is to trigger a userland page fault. So yeah, it's cool. It's another privileged access never bypass. Like I was saying, it doesn't affect CPUs that have hardware support for both PAN and UAO, but it does affect CPUs that have hardware support for PAN but not for UAO, and obviously ones that don't have it for both. For both, it's actually worse because they mention another issue where kernel page table isolation, because of changes to that, schedule isn't atomic, so you can actually race PAN, I think. You can race that instruction or whatever. So yeah, it was just kind of a commit that went out there that we wanted to talk about. It is I might have messed up that last one a little bit just because it is, I'm not familiar with too familiar with page tables and stuff like that. I don't normally go that low level when I'm working in kernel stuff. I'm usually a bit higher than that. So but yeah, this is a low level issue, and it's kind of similar to what we talked about in episode 24. It's always fun to talk about these low-level mitigation bypasses in the kernel and stuff like that.
Yeah, that's the thing that stood out to me here. This is a low-level mitigation. Really easy to understand what happened. And we've talked about that before. I think the last time we were talking about the PAN bypass, it was another thing that was pretty easy to at least understand the gist of what happened.
Which nowadays is pretty rare. I mean,
yeah, you
when
see that
mitigations, it's usually pretty complex bypasses, but
yeah,
these ones aren't.
So it's nice to kind of see. It's not so nice for the users of it, but on the exploit development
nice for
side,
the people who put all the effort into making those mitigations work, I suppose.
Yeah.
But yeah. So getting back to high level, Cisco also put out an advisory for Webex meetings, Webex Meeting Suite, and Webex Meetings Online. Unauthenticated meeting join vulnerability, and this is another one that's just a really stupid issue. If you have a known meeting ID or URL, and you have a mobile device, so if you access it from a mobile device web browser, when you go to that URL, it'll request to launch the application for that, And then if you do launch it through the application, it just bypasses the authentication. So if you have like a password protected meeting, you can just bypass that password check through the app.
It bypasses it, and kind of. It includes, I believe it includes the password, essentially. Like, you don't know the password, but the password is unintentionally included when it does that transfer, when it calls out to the Webex mobile application. Otherwise, I think you're right, but it sounds like some of that meeting information gets exposed during the join flow on the mobile applications, like the password that ends up being included. So that's where it comes. So it's not like the password just being avoided. It's that you're unintentionally being given the password when you probably shouldn't have been. Okay.
So this was patched. It doesn't need any user action because it's all on, like, you know, it's online and stuff like that. So one thing I did wonder, though, is I don't know if you've ever used these, but I feel like getting the meeting URL or the meeting ID is actually a fairly high barrier to get over. Like, you're not gonna really have that.
I feel like you can. Like, I'd have to go and look. I want to say you can brute force the number. As long as you get one, you can just keep adding one and get it.
You're right. You probably.
I want to say it's just an ID. I don't remember. I have used Webex. It's just, I mean, I was never really paying attention to what the meeting looks like.
Okay. It was just something that I was thinking about, like, you know, it is interesting that it's an authenticated thing, but even getting that meeting ID could be something that's, like, not trivial, right?
Maybe it'll be on one of those Google groups.
Maybe. So, yeah, so, I mean, it does still subvert the Office system. It's still an issue, but, you know, I thought it was worth mentioning that. You do need the meeting ID or URL to do that, so it might not be that practical to actually pull off in real-world attacks.
Yeah, I think it definitely depends on setups, though.
Yeah. So an advisory was, or a GitHub post was put up for CVE 2019 14615. So this was actually, you can see from the CVE identifier, it was reported in 2019, but I think it was just opened up to the public today, or was it yesterday? It was sometime within the next...
It looks like close to a week ago. Over a week ago.
Wow. Okay.
9 days.
Maybe I'm wrong. 9 days. Okay.
So it was at a conference.
I was looking at the README commit time, not the demo.
Yeah, no, it's definitely been out longer than that. I still thought it was worth kind of mentioning here. Because that says, you know, another Intel issue.
Yep, yet another one.
Really, like, I mean, you'll understand it pretty easily. I'm actually going to pull up the slides here. I think the slides are kind of nice.
Okay. I don't know why I thought it was out today. I just read it today, so that's probably why I thought.
Yeah, fair enough. But I mean, the gist of what's going on here is you've got on the GPU, so this is part of the integrated GPU. So not like your discrete GPU, this is integrated, so like you'll see that on laptops a lot.
Yeah.
You've got your shared local memory. So the shared local memory is like, let me see if I could find their drawing of it. Essentially,
the slides are very detailed.
The gist of this, yeah, no, the slides are actually pretty good. But the gist of this is, you've got your local memory. Like, there exists some shared memory, and then there exists memory that's supposed to just be for your application. There is some shared stuff that's like your global memory, like constants and textures might be stored in there. And then you've got your own memory for your process, your binary to run with. And essentially, when it does like a context switch between the different processes, or when one like ends and you get the memory back out, it doesn't wipe it. You're able to see what memory the other process actually had written into their memory. So you could literally just read the stack here. Here's their example for reading it. It's define a local uint on the stack and read. Yep. And you really put it out into a global. But that's all you do. You just get that shared local memory and you read it.
Yeah. And you can even, like, you're not restricted to the bounds of that array either, obviously. You can just, you know, if you want to access anything.
No, you're restricted to the size of your output. Like, you're going to write that somewhere. But otherwise, yeah, it's...
Yeah, you can read anywhere pretty much.
And that's just because it's not initializing when it loads the program, and it's not clearing when it unloads or anything. The other thing, and they don't include a lot of information about how this one works, is you're able to leak the general purpose register file. And this slide here is the most detail they have. They say that the proof of concept code will be released, but it's not yet released. And basically what this is, or what I think this is, because what they show here, for those of you listening, is they show kind of your malicious program, and they show 2 steps. They have you assembling some malicious assembly, which then produces like your malicious GPU binary, but then you do a dummy OpenCL code and compile that to get some metadata. Then you take the metadata from the dummy compilation and you replace the binary with your malicious binary. So my guess on what's going on here is this is a register file. You're basically able to kind of like say, my program is going to use like 5 registers. I'm going to use these 5 registers, and then your GPU binary will use those 5 registers only. What I'm assuming is going on here with this malicious assembly is that you basically write it and you read all the registers. You don't care about what you told the processor that you're going to use. You're just going to read everybody's register, and it just lets you do it. Is what I'm assuming the bug is, given what they've shown here, but they don't actually provide us like a confirmation of that. Because the later things just kind of go into their demos about, you know, having spyware, reading the information, you know, from the web, for example, or because this could be done out of the browser. In the browser, you're able to get code to run on the GPU. But yeah, that's the gist of it. I think the GPU register link's kind of interesting if it works how I think it does.
Yeah, we'll have to wait and see if they're saying they're going to release the POC later, then maybe that's something we can cover on like maybe the next episode or whenever they release it.
Yeah, I don't know when they're releasing it. Maybe that's something that's a little bit harder to patch, especially because, you know, the reason why they have the register, or you say what registers you're going to want, is kind of for performance reasons. So if they have to wipe all the registers and reload them like every time, like that's probably going to have a performance impact that. Well, I mean, Intel has in other cases cut corner for performance, and then they've been bitten because of that. I can't think of any instances. I don't think we've talked about that this stream yet, but
there's definitely not been you know, big fails with Intel in the last, like, you know, going on over the last 2 years. But yeah, I mean, I like this these slides and stuff like that, just because this is another like low level issue that's like really easy to understand. It's very accessible. You know, it's just information not being wiped. And I mean, that's another thing, is that it's kind of an issue that's unique to circumstances like this, because in a lot of cases you don't really care about leaving stale data in memory. And just marking it for overwrite, basically, right? But when you're talking about sensitive data and something like this, then obviously, yes, it is more of an issue that you want to consider.
Well, you're not expecting one program to be able to access the memory of like your program that ended. Like when your program's done, you're not really expecting another program to be able to access that at all.
Yeah. But it's not like an issue that you see commonly, you know what I mean? Like it's not...
I mean, it's in a sense, so... In terms of the issue from like the application level, no, but like this is essentially your classic uninitialized variable. It just happens to be that it's being done at the GPU level, but the core issue is it's just essentially uninitialized.
Yeah, it's an uninitialized read kind of, but it's different in that it's like it's from a different process. I think that's
well, it's not from an area that you're usually thinking of. You usually just assume, you know, the processor or the kernel is just doing things more or less correctly.
Yeah.
And then you find out it's not.
Yep. That's the Intel way. This is the way. But yeah, so we have some white papers as well. We have some research towards the end of our show here. And this one talks about information leaks via Safari's Intelligence Tracking Prevention, or ITP. So this talks about a privacy mechanism that was introduced into Safari in, I think they said, October 2017. So I'll be honest, I hadn't really heard of this. I'm not, you know, I obviously don't use Safari. Safari's, if you're using Windows, you're not using Safari. So, you know, it's not something I've really used, but still, I'm surprised, a little bit surprised that I hadn't really heard of it. but from what I could tell, it primarily tries to limit tracking from third-party cookies. So they establish a list of prevalent domains that are visited often, and then after a certain threshold has been met for that domain, it's added to this list called the ITP list. And it's an append-only list. You can't remove things from it afterwards unless the user history is cleared, which is obviously triggered by the user. So these domains that are added to this list, they have restrictions to remove information that would allow the domain to infer the user's identity. So in theory, this sounds like a pretty cool mechanism, a privacy mechanism. So obviously, to be able to keep track of this ITP list, they have like a global state, right? So every tab can access this ITP list. And they actually check out some attacks that you can pull off on this that are actually, there's some pretty serious flaws in ITP itself and the actual implementation. And it mostly comes down to the fact that sites can kind of side channel that ITP list, right? They can artificially add domains or through cross-site requests to this ITP list. And so they can artificially increase that to meet the threshold and check the side effects to see if a domain is in the ITP list, or if or get a site added to the ITP list themselves. So there's a few different attacks that they go through. The first one that they focus on is the side channel attack I was talking about earlier, where you can see if a domain is in the ITP list. One way you can do that is they have like a referrer header, and if you send a request that will issue a redirect, you can also pick up redirects on like no credentials on login, for example, to get that header. And I think if domain is on the ITP list, the referrer header is truncated, I think. So that's like one thing you could look for in kind of your side channel there.
Well, so the side channel itself is a little bit more on, if you have a document, unless this is a separate one, the long URL, I believe that's the first one that I see listed here.
Yeah, I think that's the referrer one, yeah.
Okay, so what's kind of going on with that? So first of all, the referrer is just if you're on the ITP list, the referrer gets stripped. It's just kind of like, that's one of those things that can tell another website where you're coming from and help identify a user. If you know what the URL is, you can like put a user ID or something to share that way. So it'll strip that. So if you're on a page, like the attacker's on a page that has a really long URL, they use the example here of 16,000 bytes in the URL. And then you make a request and this request can be as simple as just including an image out to it. And if the image loads successfully, I'll show it here. So if it has the refer link in there and the URL is like 16,000 bytes long or whatever, then when the web server gets that, it's going to give you a 413 back saying request entity too large because that header was, too big. Whereas if it was on the list and that refer header was removed, then it will succeed. Yeah.
Yeah, because the header was removed.
So it's just a way to kind of know whether or not that header gets removed in terms of whether or not load. So there are going to be false positives for that, especially if you're using add-ons that strip like the refer and the origin header and stuff.
Yeah. So yeah, that's the first one. There was a second one that was kind of in a similar vein. I think they could identify individually visited websites by inferring the number of like strikes it takes to add a site to the ITP list. So you can kind of gauge it and get more fine-grained information on user browsing habits.
Yeah, and they found that like 3 was enough to get anybody kind of on it. So they used that as their base number, I believe.
Yep, 3.
So it's not a lot of requests to do this.
Yeah. Issue number 3 also was focusing on fingerprinting. So they could like pin domains in the user's ITP list by using like random unique identifiers in the domain. I thought that was pretty cool. That's an interesting attack. The fourth one is forcing arbitrary domains into the ITP list. So this kind of causes DOS type issues when sites don't expect to be on the ITP list. So if they, like you were saying about them stripping the referrer header, if they're expecting that referrer header, but they don't get it because they're on the ITP list because some malicious site ended up adding them to the ITP list, then that's another issue that could pop up.
Yeah, well, so another thing that happens are stripping of cookies, I believe, or stripping of some cookies. So then when this other domain gets loaded, in terms of being cross-site, it's going to be missing cookies. So if you're logged in, it's going to think you're not logged in.
Yeah.
So that's another place for that. I mean, it's kind of a denial of service, but
yeah, I didn't really know of a better.
I'd say yeah. I mean, that's a bit of a stretch.
It's kind of a DOS type issue. Like, it could cause disruptions. I guess that would be a better way of saying it. It's a disruption causing issue.
Yeah, I mean, I'd say you could target that against like another advertiser. Like, oh, I'm going to make sure they can't get the information.
Yeah, and then the fifth one is cross-site searching. So you can learn about search results from a given user by inferring from the ITP list. So they mentioned some mitigations to try to subvert like those issues by limiting the length of the refer header was one of them. The other one was varying the number of strikes it takes to get on the ITP list. Like you were saying, it's like normally 3. And disabling the redirect manual ability to prevent detection of cross-origin redirects. But ultimately, those mitigations don't address the core issues. And it seems like ITP, honestly, this paper makes it look like ITP is just a system that needs to be thrown out. I don't think there's any way you could really fix these issues without doing a major overhaul on the entire thing.
Yeah, I mean, that's definitely kind of the issue at hand is, like, the principle of it isn't a bad idea, but the actual execution of it, opens up privacy concerns as much as it tries to hide. And to be fair, it does reduce the granularity of the data being collected, so maybe it is a net positive. But it does allow for some information to be retrieved.
Yeah, it's just one of those things that's nice in theory, but in practice, it just doesn't really work how they thought it would.
Well, it has unintended side effects. Again, like I said, it might be, and we'd have to take a bit more time to look at it, that the net effect of it is a positive because you're not being able to get the same degree of information because of this. I mean, it's not like you're getting all the same information you'd get if you had all the refer information. You're just able to get that Boolean answer, like, is it on the ITP list or is it not on the ITP list? Which can tell you a lot, which can do some tracking, as you've mentioned, adding the unique URL.
Yeah.
So it can do some tracking, but I don't know. I mean, I feel like there's a certain level of granularity that's missing. That maybe it isn't a net positive actually because of being able to do that unique URL. That one seems like kind of the biggest giveaway to identify a single user.
Not only that, you also have the one where you could cause those disruption issues on other websites, right? Like, is it worth the trade-off? Like, that's what I wonder. Is the trade-off of having a little bit less fine-grained data worth the potential disruption of users, like services of other websites, and the fingerprinting ability?
Yeah, so
I don't know.
It's a fair question, and I don't know until I maybe spend a bit more time looking at this, but the one thing that does kind of come to mind is Google's already kind of doing a little bit of work, like we talked about the same site cookies before and stuff. Those are also kind of disruptive in a similar way. So perhaps that disruption is going to be a bit more acceptable.
Yeah.
As people just kind of adopt or adapt to it.
Yeah. It's just something you gotta kind of weigh.
Yeah, it's definitely a fair point. Like, I'm not disagreeing with you. I'm just leaving it up in the air, undecided.
Yeah. I thought these attacks were kind of clever. I particularly like the fingerprinting one. I thought that one was kind of an interesting way of abusing the ITP list. And yeah, so the attacks are clever. It exposes weaknesses that can't really be solved easily. Yeah, so I'll be honest, like, I don't use Safari, like I was saying. I didn't even know this feature existed, but I think this paper is really cool. The ITP list stuff I found interesting. I think you didn't find it quite as interesting as I did, Z, but I mean, yeah, I think some of these attacks were kind of cool.
It's not that I didn't think some of the attacks were cool. I just found the paper itself to be kind of boring to read. Like, a little bit dry, but that's just my opinion. I'm not saying it's a bad paper or anything. Maybe I'm just having a bad day.
Okay, yeah, I liked it, so that's all that matters to me. But here's a paper that you did find interesting, and that was GhostImage. So this was a perception domain attack against vision-based object classification systems. So obviously we've talked about classifiers and AI in the past, mostly in a negative light in terms of how you can attack them through like adversarial samples and stuff like that.
This is still in the negative light.
It's still in the negative light, yeah. So you really like this, so I think I'll let you talk about it because
so I definitely do. I like this attack. I mean, it's not the most practical thing. The gist of what's going on is you're either able to prevent a camera, an AI camera, from detecting something, or you're able to project an image of something that it will detect into it. And this is done externally from the camera. Although, in the best case, you do have some knowledge of the camera. But yeah, so jumping in, if you're not familiar with the idea of ghosts just in photography, if you've ever taken a picture and you get it, well, I was going to say you get it developed, but you just look at it on your phone these days, but you get the picture and you see those little kind of tiny specks in it, like maybe just like a little speck of light somewhere that shouldn't be, that looks almost like dust on the camera. Those are called ghosts, and what's happening is when light kind of hits the lens, usually it should just go straight through the lens, straight through the glass, and out the other end into the sensor. But what will sometimes happen is, if it just has the right angle, some of the light may get reflected inside of the lens and get reflected either back out and then get reflected back in on the other end of the lens, and it might do that a few times until it actually hits the sensor. And that's what creates those little specks on your pictures, if you've seen that before. So this is kind of taking advantage of that idea. And it actually does explain exactly what I was just saying about how those ghosts kind of get formed in this paper. But what they do is they take the idea of having like a off-the-shelf projector and being able to project and control kind of what colors show up in different images that can show up by having like the projector, and then projecting, in their example case here, they project a merge sign on top of a stop sign. And just projecting the image. I don't know. I think it's just a really cool idea. I'm not sure if it's unique to them. I actually don't think it is. But the other cases have just kind of looked at using lens flares. So obviously you shine a bright light into a camera, you get the flares to kind of obfuscate what's being seen or hide it so it can't actually be detected. And they talk about doing that here too. But practicality, distance 1 meter, they're having like, 50, not even 50%, it's 41% being able to inject it from 1 meter away, and 5 meters away, 10% success rate. So go ahead.
Sorry, I saw they were comparing like digital and perception. So perception, was that like doing like the projector thing, and then what was digital, like digitally introducing the ghost image?
Yes.
Okay. I was just a little bit confused when I was reading that earlier too.
Yeah, I believe that's what it was. And to be clear, they also go into kind of modeling the projector camera to adjust to actually get the values a little bit higher from the creation attacks and stuff. They do go into kind of trying to model what the projector actually does and how it changes the colors in order to have a little bit more success. But I just think the idea there is really neat. Obviously, it's not super practical to, take a projector out on the street. But I mean, even 10% at 5 meters away, you have a lot of cars going by. Like, you could potentially do something with that.
Yeah, there's a possibility.
But I don't know. Using this whole idea of ghosts to recreate an image, I think is a fun attack. I can't think of any way to include that in like a CTF challenge, but I think it could be a fun challenge if you have like a live CTF.
Yeah. I mean, I think it's cool, like, especially because, they mentioned that you can pull off two kinds of attacks. You can pull off creation attacks to fool the camera into thinking objects that aren't there are there. And the obfuscation attacks to fool the camera into thinking an object isn't there or misclassifies it. And I thought the ghost image, like, this is probably, like, a lot of the papers we read that cover AI and, like, fooling object classifiers have really, like, weird, questionable names. This one, I think, is, like, most apt name I've seen. Like, ghost image. It just seems so appropriate. And it's, I don't know, I thought
I
they
agree.
deserve some props for that. But yeah, like, it's definitely, it's a cool attack. It's a very fitting name. It's a cool premise. But yeah, like you said, not too practical. But I think like you, I agree. It's a fun paper.
Yeah, and it could become practical as, you know, the technology for the lasers becomes a bit more effective, or I guess not like the projector, sorry.
Yeah.
Like as that becomes more effective, like there are ways that this could become more effective. So, you know, as is often the case with a lot of these papers, is it's the seed of an idea. Somebody might run with this in the future and actually make it practical, but this is just, here's the idea and some research related to it.
Yeah. So we'll move into our shout outs of the podcast. So you had a shout out that you wanted to bring up called Nightmare. So I didn't really get a chance to look at this, so I'll let you take this one away.
Yeah, so I saw this actually a couple weeks ago, so this isn't super new, but I initially ignored it. So the way it's described here is, I'll actually say the way that I saw was it's just a collection of binary exploitation / reverse engineering challenges and write-ups. In their description here, they say it's a course based around CTF challenges. I didn't see that when I first saw it. I was thinking this is going to be something kind of like Shellstorm. Like Shellstorm hasn't been updated in a while, but they used to have a CTF binary collection, then just adding some write-ups, like mixing those in there and whatever. What this looks like, though, is it's a lot more organized. So I've kind of opened up the nicer static site they've got there, but it is just challenges plus write-ups. It looks like the same person did all of these write-ups, but what's important here is it's very organized.
Wow, that looks actually pretty cool.
Exactly,
that's categories for all the bug types and stuff.
Yeah, I mean, not all the bug types, but they have a lot of bug types in here that becomes really useful if you want to go and learn. If you want to, so it does kind of spoil the challenges because you know what type issue you're going to be dealing with. But when it comes to try and learn, it's, you know exactly what type challenge this is, so you're able to focus on learning that technique. So it's not going to help you so much on the discovery. Still can help because you learn how the bug's actually abused. But yeah, like obviously what I've got up on the sidebar here is their ROP section. They've got, you know, dealing with partial overwrites, stack pivoting, SIG-ROP, so signal ROP. They've got heap stuff. I mean, some of these aren't great. Like the use after free one, it's a single, just like you get the code, you get an explanation. It's not as much of a challenge. Then they've got like for fast spin attacks, some of the house attacks, House of Force. So yeah, I mean, just because it's so organized, I think this is actually a really awesome resource to go and take a look at if you're wanting to learn, if you just want to have some to practice, you know, see if they've got what you want to learn on here and go try the challenge out. Tons of write-ups in there, and like I said, it looks like a lot of them are written by the same person. I noticed with a lot of these, it starts off, let's take a look at the binary, and if you click around in here, let's take a look, like all of these just have kind of that same phrasing, which makes me think that it was written by the guy in a tuxedo, which also makes it a lot better. And that's his GitHub username, which makes it a lot better if it is just one person doing a lot of these write-ups. Again, kind of what I thought when it's saying just a collection of, I'm thinking, okay, so they're just going to pull down, you know, like CTF time will list the challenges and, you know, you can get links like that and just kind of pulling all those things together. But this looks really well organized and structured, such that like I've gone and added it off to my kind of usual recommendations for stuff, because this is it's really well organized. It's a lot more than what I thought it was going to be, and I'm glad I did finally, you know, take the chance to look at it.
I mean, even more, like you were saying, this is good for beginners, but I think there's another use case for this, is if you're doing like a CTF or something like that, and you want to quickly reference a bug type or something that you're dealing with in your CTF, it can be a pain in the ass sometimes to like try to Google search for some write-ups and then, oh, this write-up isn't the one I wanted anyway. It doesn't really cover what I'm thinking of. I think this could be a great resource even for when you're doing CTFs, just to try to find issues similar to the ones you have, and being able to quickly refer, you have like a quick cross-reference to previous CTF challenges that could be similar.
Yeah, and to how the exploit works, or the technique works, yeah.
Yeah, so I think it'll be really useful for that too. I think it'll be useful for CTFers, even if you're not necessarily a beginner or anything like that. So yeah, that's a cool resource. I have a few shoutouts of my own. These would have been in our exploit section, but because I just found them today, I didn't really get a chance to look over them, so I can't talk about them too much. That's why I wanted to do them as kind of a shout out. The first one I have is a blog post by GR Security, The Life of a Bad Security Fix. And this is about a fix that got introduced into I think it was a Linux kernel. And I think it was like a race condition. And then they tried to fix it by introducing a lock. And then that lock ended up actually introducing a new bug, which was a CPU stall. Like it had a deadlock. And they ended up putting this patch in. It ended up getting backported to previous versions, and it created kind of a mess. Because you just you continuously hold this lock, you get a deadlock, and it was introduced as in a fix for a previous bug. So I think it was kind of interesting to bring up, just because it is kind of not something really we see too often, but probably isn't too uncommon either. And we talk about kernel stuff a lot, especially when it comes to locking and stuff like that, and how hard it is. And this kind of highlights that, just that how easy if you introduce a bug and trying to fix another bug, that kind of speaks volumes about how hard locking can be to do properly.
Yeah, and actually looking at this one with the locking there, it kind of goes back to what I mentioned, where there's this new return path. So it's another sort of early return that results in the bug.
Yeah. Yeah, which is very common in kernel. So cool write up. The other one I had was actually a piece.
Just before you go there, I was going to mention there, that's actually one of the reasons why a lot of times in kernel you actually see them using go-tos instead of just returning. Yep. Is exactly for reasons like this. You do a go-to to your handler for doing everything that needs to be done, and then returning. It's really for cleanup purposes. That's really one of the only reasons I can see to use go-to. And that's why you do kind of see it. It's not being used here, and of course you see the bug.
Yeah. So just a couple hours ago, there was also a Project Zero report that was made public. And it was in macOS and iOS. Their ImageIO, which I think is a library, it has heap corruption when performing a malformed TIFF image. So there's some field in there. I forget exactly which one, but basically... I think it's bits per sample. You can kind of mess with that to get some incorrect math going on, and you eventually get a heap overflow because you end up writing more than what's allocated. It doesn't really look like something that can be easily exploited, because I think they say the buffer is M-mapped, and usually when a buffer is when it's M-mapped like that, unless you have control over a vector that can get you arbitrary M-map or something like that, it's probably not easy to exploit. It might not even be exploitable, but it did come out, and I did want to mention that because I saw that on my Twitter feed an hour before we went live. So I just did want to quickly shout that out if anyone's interested in checking that out.
Yeah, no mention. I mean, a lot of times heap corruptions are always kind of interesting to exploit because you never really exploit them in a straightforward way. No. There's always more to doing maybe not always. I mean, maybe you've got a function pointer sitting on the next to it in memory, but generally speaking, there's always a little bit more to working out, doing some feng shui or whatever you want to do. Or
you say it like that? I was gonna say that too. I was like, yeah, you normally have to do heap feng shui, but I think you say feng shui, or how do you say it?
Well, now that you're asking me to say it again, I'll mess it up. But feng shui.
Oh, okay.
Is how I believe that's how it is said, but.
Okay, maybe I'm wrong.
The place where I'm remembering kind of learning how that's said, I'm pretty sure it was a cartoon as a kid.
Oh. Okay.
I don't remember what cartoon, but that's what I'm thinking of is some cartoon. So I might be wrong. Nonetheless, I mean, you're doing a lot of that sort of stuff with the heap corruption. The heap issues are often getting pretty complex. I mean, at least if you're actually able to attack the heap, if you're able to do something else with that heap data, it's the same as any other memory corruption, but so that just the reason why I'm bringing that up is because it might be exploitable because it's heap.
Yeah.
Obviously, I'm seeing this for the first time right now, so I don't know.
Yeah, I didn't get a chance to look into it too much, but I did want to bring it up because it looks cool. But yeah, that pretty much concludes our shoutouts. So Yeah, I think that's where we're going to wrap up the show. We don't really have any more topics. I do want to say before we close it out, we do have our YouTube channel that has all the VODs and stuff on it. Go ahead and, subscribe over there if you haven't already. We also have a Discord. If anyone's interested in joining that, you can join that. Link should be below in the Twitch channel. If it's
it is. Link is below. I mean, it's just we are trying to grow the channel out a bit, both here on Twitch or even just Spotify or wherever else you want to listen to us. Just want to ask if you like us, do give it a share. Just get the word out there. Obviously, we don't have a huge reach at this point. It would be nice to have some more listeners. So those little things do kind of help us.
Yeah, absolutely. So yeah, if you like our podcasts and stuff, be sure to share it, subscribe on the YouTube and stuff like that. But yeah, and you can ask questions in the chat as well. Feel free to do that anytime during the show, and we'll try to address it after we're done talking about the current topic. But yeah, so like I was saying at the beginning, we will be getting back into doing the streams on the Fridays. Not sure what we'll be doing this Friday, but we'll figure something out. And obviously we'll be back again next week at the same time, 3 p.m. Eastern, 1 p.m. Pacific, I think, with the next Day Zero podcast. So yeah, thank you guys all for watching, and we will see you guys next time.